So hello everyone, I am Mohammed, and today I'm going to do a lecture about subsea plant engineering. Here, a short look to the contents, what you are going to talk about. The subsea production system, the Christmas tree, subsea pipelines, production risers, subsea pipelines burst, and finish corrosion protection. Subsea protection system. First of all, why is subsea plant engineering interesting? Rather than ocean surface engineering, where the structure needs to be very complicated and sophisticated, it allows to have a solution that reduces the work and so the cost. We can reach the deepest ground much easier, and so it is possible to get more oil and gas from the deep ocean that we would not reach easily with like an offshore normal structure. The cost of the riser, which is the connection between the structure and the host facility, like an FPSO, gets bigger. The price gets really high, especially when depth is very large. Engineers want to extract only valuable material from the well and deliver it to the ocean surface. And with a subsea factory, we can have many little facilities which will make, in addition, a very big structure. On this picture, we can see the typical field layout. Gas and oil are coming from the well. You have here trees and wellheads, and under there you have the wells where the oil and gas is coming. They collect the gas or oil through the pipelines, and the collection is done and combined into the manifolds. In these manifolds, there are much bigger pipes permitting the transit of the gas up to the risers and finally to the host facility. The umbilicals here are electric cables coming to the system and sending them the instruction and the control. Here, a short video.
Compared to a compressor on a platform, Åsgard subsea compression substantially reduces CO2 emissions and is far more energy efficient. Let's have a look at how it works. As gas is taken out of the reservoir 2,500 meters below the seabed, the pressure decreases and the flow crawls to a halt. The compressor is then installed to actively suck out more gas and condensate from the geological formations. First, the compressor cools the incoming components and separates fluids from gases. The gases are then compressed, cooled once more, and mixed back with the fluids before being pushed to the receiving facility at Åsgard B. To avoid fluid blockage in the pipeline, the compressor maintains required flow at all times. The key to the subsea compressor's efficiency is its proximity to the wells, allowing both sucking from the reservoir and pushing through the pipeline. The subsea gas compressor on Åsgard is also vital to the next step for subsea processing, the complete subsea factory. Constructing self-contained seabed installation.
Like I mentioned, we can install a lot of facilities which will make a very big factory under the sea. Don't underestimate the size. On this picture, you have a manifold, like we saw before. The structure is quite impressive. You can see the size of a human being right next to it. And with two manifolds this size, you can produce around between 700 and 2,500 cubic feet of gas per day. In metrics, it represents about 20 to 71 cubic meters per day. I mentioned the trees, which we call also a Christmas tree, on the wellheads. Here you have the difference between an onshore tree and an offshore tree. The difference is very large. A Christmas tree is this device. It is an assembly of valves, spools, and fittings used for gas well, oil well, water injection well, and other types of wells. The surface pressure control is provided by a Christmas tree, which is installed on top of the wellhead. So this is the device that prevents or control the pressure fluctuation. This, for example, is an onshore tree, but the principle is the same for an offshore. Here is a subsea wellhead. One of its purpose is to make possible to drain the gas from the well, and also to protect all the system by closing the flow if ever the pressure becomes too high or there may be a danger. Like I said before, we can see that the Christmas tree are composed with many devices. Subsea manifolds. The manifold is an arrangement of piping and or valves designed to combine, distribute, control, and often monitor fluid flow. We can compare the system to an engine of a car, where the gas from the cylinders are collected into a manifold, and after that, the gas will be rejected. Subsea manifolds are installed on the seabed within an array of wells to gather produced fluid or to inject water or gas into wells. Subsea pipelines. Normally, the term subsea flow lines is used to describe the subsea pipelines carrying oil and gas products from the wellhead to the reservoir. Here we have the food which is fixed on the seabed. It's not always the same. This is the design of the processing of a pipeline. If you're interested, you can watch it in detail after. The pipeline installation. This is the way how pipelines are installed. There are big ships which bring the pipeline to the installation point. And as you can see here, they make possible to install them on the seabed. They have to be very careful when manipulating them, because these pipes are very long, very heavy, and of course, very expensive. So to avoid any risk of damage, they have to control the bend here of the pipe, and always keep the angle very large. Another video to show how they are installed.
아, 이거 진짜 그만둬야 되나?
사업을 접어야겠구나 이런 생각도 들고.
솔직히 말해서 현타가 좀 왔었습니다.
This is a drill. They use it to make the holes in the seabed and to get the wells. Production risers. We have many types of production risers. The major difference is the structure. They are all made of different layers, going from steel to flexible insulation material, in order to avoid any risk when rising up the gas to the hostess. This, for example, is a picture of a riser being cut, so we can see how it is made inside. And as a professor said before, we want to avoid that the riser breaks down or that it made the ship or the FPSO going down. So in order to avoid this, we use, there are different options. And these kind of configurations are obtained by using buoyancy, which are these things which make possible to have the riser here going up and not here, and to lower the stress here or on the structure. Here another picture. Subsea pipelines burst. Sometimes there can happen an accident and the pipeline can burst like we see on this picture. When it happens, the oil or gas will leak in the ocean, and then we will have a very harmful situation for the environment, and also a very big loss for the client who is losing money. To avoid this, the flow pressure should be always controlled, and the pipeline should be cleaned sometimes or even replaced when it becomes too old. But when a burst happens, the pipeline has to be repaired, or yeah, it has to be repaired. But it is quite complicated to do it in a depth of 1,000 meters. In this case, diving is not possible, and we use usually ROV. Here are some other pictures of broken pipes. We have also to avoid failure when assembling the system. Here we have a little opening here, which finally concluded in total erosion of the inside. And if this happens, you have to change not only maybe the pipeline, but also the connection piece, which can be very complicated to change, very expensive. Here, a depression in an oil pipeline made a very big deformation. Corrosion protection. Why is it important to have a corrosion protection? Corrosion is an electrochemical interaction, and we want to avoid it to preserve our system. And as we can see on the picture, even steel with this thickness can be eroded and be useless. Replacing it will cost a lot of money and a lot of time, and we want to avoid both of us. Thank you.
Hi, Steve.